Hello, today we're going to talk about multiplying complex numbers and imaginary numbers for that too. So we need to remember two things. We need to remember about when we multiply two like bases, so we have a and a. When we multiply like bases, we're going to add the exponents. So we have something like this. If we had something similar to, say, x squared times x to the third, we would say that that is x to the 2 plus 3, which gives us x to the fifth. So when we multiply like bases, we're going to add the exponents. And then we also need to remember reducing I to the first power, or always to a power of 1, using what we learned about simplifying complex numbers and imaginary numbers. So we're going to look at this and kind of build our way up. So looking at this, we have 3i times 4i. So we have two imaginary numbers multiplying together. And we're going to treat a lot of these similar to x's. It's just when we need to know that they represent something other than x, but also that what we need to reduce down to I to the first power. So if we were to have this in a similar format of 3x times 4x, we would say multiply the 3 and the 4 to get 12, and then we would get x squared. Well, everything's going to work very similar to that. We're going to say 3 times 4 is 12, and then I times I is I squared. But then we need to remember that we cannot leave that as I squared. We need to reduce down. And we should know that I squared is going to be negative 1. And so that's going to be 12 times negative 1, which gives us an answer of negative 12. From there, we look at multiplying a real number by a complex number. So we just need to distribute. So distributing in here, we're going to say 3 times 5 is 15 minus 6i. And from there, we can see that that is in standard form, remembering that standard form is a plus bi. And so we need to write that in that order, which this already is. And we can't do anything else. That is our final answer. Checking that we have any powers of I is just to the first, so we can leave it just like that. Looking at the next few, now we have a complex number times a complex number. And similarly, if we had, x plus 6 and 5x plus 3, we could FOIL this out. Well, you're going to do a similar process. And we can either FOIL or double distribute, however you want to talk about it. So 6 times 3 is 18. 6 times 5i is going to be 30i. And then we have negative 2i times 3 is negative 6i. And then negative 2i times 5i is going to be negative 10i squared. Now you have to be careful, and I would always combine like terms first. So we're going to say 18 plus 24i minus 10i squared. Now we need to remember that we can't leave this I squared, and as we talked about before, we should know that that's going to be negative 1. So we can say 18 plus 24i minus 10, and we can substitute in that we should know that this is negative 1. So what that's going to do is going to leave us with a positive 10 over here. So we're going to have 18 plus 24i plus 10. And that should give us 28 plus 24i in standard form. Looking at the next one, we need to recognize that we cannot distribute the exponent. That is not how order of operations work in this manner, because we have addition in the middle. So we need to rewrite this as 2 plus I and 2 minus I. And then we FOIL or distribute how you did before. So we're going to say 2 times 2 is 4. 2 times negative I is negative 2i. I times I is positive 2i. Sorry, that should be a positive. So that should be a positive. So we have positive 2i and then plus I squared. So if we have that, we can combine like terms. And we should have 4i here. And then we have plus I squared. As before, we should know that that is negative 1. So we'd end up with substituting that in to get 4 plus 4i minus 1. And this should result in 3 plus 4i. Making sure we're in standard form. Lastly, we can look at working with radicals in this manner. So if you are ever given a radical, you need to, with a negative underneath it, you need to simplify the i's before we do anything else. So you can't multiply negative 2 times negative 14, or else you will miss out on part of the problem. So we need to make sure that we know that this is going to be, as we talked about reducing in the previous video, that reducing this should be negative 1 times 2. And so that's going to be root 2 I. And so because the square root of negative 1 will give you I. Similarly with this, we can say that this is negative 1 times 14. So that's going to be root 14 I. And so when we multiply these together, so we're still multiplying, this is going to be root 2 times root 14 is root 28. And we're going to get I squared. Well, we should know that I squared is negative 1. And so that's going to reduce to be negative square root of 28. And then we need to look at 28, and we should see that there's a factor of 4 in there. So we can say that this is 4 times 7, which is going to be negative 2 root 7. So you need to make sure that you are simplifying the i's before you do anything else. Number 6, you can do the same thing in the same manner. There's 2 ways to do that. Is that we can, again, kind of like what we talked about on example number 4, we could say that this is square root of negative 18 times the square root of negative 18. Simplify our i's, so we could have root 18 I times root 18 I, making sure that the I is not underneath the radical. And then we would get 18 times 18 is 324. And then I squared. Well, we know the square root of 324 is 18, and we're going to get a negative 1, so this becomes negative 18. We should also be able to recognize that anytime we have something, the square root of something squared, then that's just going to undo each other. They're almost like inverse operations, and so we could just jump right into saying negative 18. But either way will work. So main takeaways are treat them similar to variables when you have complex numbers or imaginary numbers, and then reduce your powers of I. If you have a radical with a negative underneath it, you need to simplify with i's first and then use regular radical properties. So I hope this helps you with multiplying complex numbers.